So the next lesson, according to the chemical reactions in alkenes. So previous lesson, we already learned once of the preparation in alkene, which is we can call dehydration of alcohol. And we recall it back what we have learned before. Dehydrations mean remove. Remove what? What compound? Hydration means the process involved is elimination of the water. So the type of process must be type of reaction must be elimination reaction, and what is the specific reaction according to the name of the reaction, dehydration, and what is the compound used as your reactant, and this is the alcohol. And we recall it back what happened by using the strong acid, which is a concentrated sulfuric acid, a concentrated phosphoric acid, undergo process heating. So we try to eliminate for molecule of the water, and we finalize from the carbon-carbon double bond. So remember the rules for here. During to the formations of the major product, we must be consider one rules we can call Sazef rule. This Sazef rule is used to determine a major product which is have highly substituted of the carbon double bond. Means according to the final equation here, we just have a comparison. One is a minor and one is a major. Means if the equation given to you two product form or more than one product, means in a step mechanism we have a stage of rearrangement. So how about the major product? It must be have your carbon-carbon double bond attached to 1, 2, 3 alkyl group. So this is a major product according to the Sazef rule. So this is our chemical reaction. So I just go through only. This is our previous lesson. Okay, so we are focused to the example number 4. If you refer to the example number 4, we have a 3 product form. What is the meaning for the 3 product form? Means this process involve rearrangement. So first, carbon-carbon double bond attached at here, second here, and finalize for at this part. So the major product must be have the more alkyl group attached to the carbon-carbon double bond. So this equation consists of step rearrangement in step mechanism. So focus for today, rearrangement based on to the mechanism dehydration of alcohol. So I just go through apa yang melibatkan dehydration of alcohol. So you can refer to our video. So to study for this lesson. So the first step in step 1, okay, it must be used the arrow full-headed. From where? From the side of nucleophile, which is the reach of electron density, toward to the less electron density, we can call electrophile. So we have a 4 several step in mechanism. Protonation of alcohol, formation of carbocation, and rearrangement either or not depend on the stability carbocation formed in the step 2, and finalize the formation of alkene. Next, the second preparations of the alkenes must be from the alkyl halide or haloalkenes, means the Rx compound consists of the halogen as our functional group. The process involved also D, mean the process is elimination, remove hydro, which is hydrogen, and halogen, which is eliminate X. So what is your reagent involved? It must be carried out by using a strong base, and your solvent must be alcohol. So this is our several reagent use. Alcohol, ethanol, and another one is reflux. This is our condition. So this is our solvent lah. Okay. So sodium ethoxide, ethanol, and reflux. And then sodium ethoxide, methanol, reflux, and potassium third oxide in third butyl alcohol. Means the another condition also you must the presence of reflux process. So this is a general chemical equation for the dehydrohalogenation. So KOH ethanol ataupun any alcohol and reflux condition, and we need to eliminate H and X. By using the Sazef rule, we can determine as a major product for the carbon-carbon double bond. Or you can write the equation as a if no need to write down plus, you just write down the arrow. But our reagent strong base must be up of the arrow, comma, our solvent, alcohol, next stage condition is reflux at the below arrow. So finalize, the elimination occur, the carbon-carbon double bond form plus HX. So sorry, this is our HX. Okay. So according to the chemical equation for here, example page 97. So this is example 1, page 97. Okay. So the reagent is CH3ONA, solvent is alcohol, and next stage is a reflux. So what happened? We eliminate chlorine and another one hydrogen. So mean our side product here is HX, which is HCl. So the carbon-carbon double bond form here. Similar for this part. Okay, eliminate bromine and one of the hydrogen. So the new carbon double bond form. And same for the equation number 3, but this condition based on to the one is a major and one is a minor, means maybe this mechanism consists of the formation of stability carbo, okay, tanyon. So in this chemical reaction, no mechanism involved in your syllabus. So we just must be understand about how the product form according to the chemical equation. Okay, now we learn about the how alkene reaction means from the alkene we can produce what class of the compound new. So basically the chemical reaction is always take place at the functional group carbon-carbon double bond, and this carbon-carbon double bond will become nucleophile site, and the most active reaction is must be it will condition as a addition of electrophile species, and the type of reaction is electrophilic addition reaction. So this is a several equation involved in our chemical equation. So this is our hydrogenation, name of the process hydrogenation. Our reagent is hydrogen, and the catalyst is a nickel, palladium or platinum. Okay, the second is the halogenation. We divide by 2. Halogen in our inert solvent, halogen in water. So we have a differences of the product form, and the part C, hydrohalogenation, also 2 condition. Okay, the first is peroxide and another one is without peroxide to process. And for next part, hydration, the formations of the alcohol, and last part is oxidation. We have a 2 process by using potassium manganate solution. We have a 2 condition, hot acidify, and another one KMNO4 cool, which is base, dalam keadaan berbase, and finalize is ozonolysis. So the 3 equation here is a process of oxidation. Okay, so this is the summary of the chemical reaction involved in alkenes. So the recap for the first thing. Okay, blue color means chemical reaction, it consists of reaction, and the green color, this is a preparation. We have a 2 chemical reaction. So which one have the mechanism? First mechanism, and then next second mechanism, and third mechanism. So as conclusion, in the chapter alkene we have a 3 mechanism reaction. Okay, for the first reaction in alkenes, we consider as the hydrogenation. So our reagent is the hydrogen, the presence of catalyst either platinum, palladium, nickel. So the process is must be added. So we add a 2 hydrogen atom neighboring together in our carbon-carbon double bond. Means from the unsaturated hydrocarbon produce saturated hydrocarbon, which is alkene. And this is a chemical equation for the example here. So for example, the carbon-carbon double bond and our reagent is the hydrogen. So we add one of the hydrogen atom and this is part second hydrogen atom. So no rule involved. Similar for the second question, from the carbon double bond will become single bond means the process involved we add the hydrogen atom neighboring carbon together. Next, the preparation for here, which is the including the chemical reaction by using the halogen is our reagent, but the condition is two. First, by using inert solvent. Second, by using water, and the reaction takes place also based on to the symmetrical molecule. So the condition either two. Okay, we go one by one first. Okay, what happened? The additions of the halogen in inert solvent. So, inert solvent is writing compulsory, but this inert solvent cannot involve in chemical reaction. So, what happened? We just add a 2-atom halogen into the carbon-carbon double bond to form saturated compound, and they are single bond and halogen is added neighboring together. So, therefore, the product form here we can call vicinal dihalide. Means halogen will added to the neighboring carbon together. So in which is from the carbon-carbon double bond. So according to example, from the carbon-carbon double bond number 2 and number 3, the process involved we just add halogen, chlorine, without disturbance of inert solvent. So this inert solvent only as a solvent with the halogen only. Similar for this question 2 and question number 3. Okay, so what happened if our solvent is water? So this is our reagent. As a conclusion, water also solvent, but in halogen we add 1 atom halogen. In water we add OH group. Okay, so what happened? So this is OH group become negative charge. Halogen basically will added become partially positively charged. So if this is differences of symmetrical, okay, so we have a factor for here. But according to general equation, halogen and hydroxide ion must be added to the carbon adjacent together, and this product we can call hydrohydrin. But if we have the unsymmetrical molecule, which is differences of number of hydrogen atom, mean hydrogen at the carbon number 1 is greater than hydrogen at carbon number 2, bromine must be added first to the carbon double bond. So, di mana dia akan cari follow Markov-Nikov. So, bromine added pada carbon double bond that have higher number of hydrogen atom, and neighboring carbon barulah kita add OH here. So, this is does not have the mechanism, but we must follow one rule we can call Markov-Nikov rules. Basically, dia akan cari juga hydrogen atom dalam carbon double bond. So, this is the main of the Markov-Nikov rule, which is addition of hydrogen halide. So, by using the hydrogen halide, HX kamu either HBr ataupun HCl. Who come first? Added H plus ion dulu. Kenapa? Sebab H plus is electrophile species. And the type of reaction must be electrophilic addition reaction. And next place, halogen must be added adjacent carbon together to form haloalkene. So this is the symmetry. Why symmetry? At the carbon-carbon double bond, we have the similar number of hydrogen atom. So hydrogen added either one. It can added carbon number 3 or it can added carbon number 2. This is similar part. Syaratnya final answer must be produced haloalkene. Okay, next. Okay, tetapi if you have the unsymmetrical alkenes, means according to the carbon-carbon double bond, we have a differences of number hydrogen atom. So at the carbon number 1 here, we have a 2-time hydrogen atom, and the chemical reaction take place. The first species must be added to the carbon-carbon double bond, must follow Markov-Nikov rule. Apa Markov-Nikov kata? The addition of the hydrogen atom into the carbon-carbon double bond must be have at the greatest number of hydrogen atom. Next stage, barulah halogen masuk pada adjacent carbon. Okay, so this is a process involved. Okay, so this is why according to here we have the H plus ion and Br minus ion. So H masuk mana? H mesti masuk carbon nombor 1. Br masuk carbon nombor 2. So this is bila dia follow Markovnikov rule, kita boleh clarify produk ini sebagai the most major product sebab dia menggunakan Markovnikov rules. Okay, so similar for this example. Okay, sama saja kita trace ini banyak hydrogen. So this is why at the end of the chain kita ada addition of another one hydrogen and neighboring carbon here barulah dia add bromine atom. Similar for the cyclic compound, di sini dia dah ada satu hydrogen, finalized product dia akan dapat total dia 2 hydrogen. So this is also unsymmetrical molecule follow Markovnikov rule. So this is the mechanism addition of the hydrohalogenation in alkenes. We have a 3-step formation of carbocation, rearrangement and nucleophilic attack. So you can refer to the next video. So how about the addition of HX but specific hydrogen bromide, the presence of a peroxide. So the presence of peroxide here either H2O2 or CH3 or CH3. So if your reagent consists hydrogen halide, which is hydrogen bromide, the presence of the peroxide together, so this reaction must be follow anti-Markovnikov. So bila anti, first step, hydrogen akan masuk pada carbon yang kurang hydrogen atom. So this is why the another one hydrogen is added. So Br masuk for the neighboring carbon. So final product still same, halo alkene. But the process involved is difference rule. Anti-Markovnikov dengan kehadiran peroxide, our reagent is only hydrogen bromide. So this is a one of the chemical reaction. So we have the carbon number 1 and carbon number 2. So carbon number 1 without hydrogen. Carbon number 2 we have another one hydrogen. So this is why final product at the carbon number 1 here no hydrogen added but we add a bromine. And the carbon number 2 here we have extra another one hydrogen atom. Okay, so tetapi soalan ini kenapa final produknya begini? Oh, sebabnya sekarang ini produk dia hydrogen masuk pada hydrogen yang banyak carbon, yang banyak hydrogen atom. Bermaksud ini adalah Markovnikov rule. Kenapa Markovnikov? Because no peroxide at this area. Tetapi the second question ada peroxide. So it must be anti-Markovnikov rule. So we check carbon 1, carbon 2 consists hydrogen. So hydrogen added pada carbon here and bromine added carbon number 2. Addition of acidify for water. Okay, so syaratnya reagent kita must be water and H2O ini sebagai catalyst. Siapa catalyst kita? Catalyst kita dia mesti dilute solution. Who is our specific compound? Either H3PO4 or H2SO4. So this is why our catalyst is a dilute. We can writing simplify only H3O plus and water consists H plus ion and OH minus. So means we add the OH and H plus neighboring carbon adjacent in the carbon-carbon double bond and finalize we can produce alcohol. Okay, so this is a chemical reaction involved. So we check first. Okay, so carbon number 1 consists of 2 hydrogen atom. Carbon number 2 only 1. Our reagent is water, so ada H plus, ada OH minus. So who added first? H plus must be added first. Di mana? Carbon nombor 1. Sebab itulah at the carbon number 1 we have another one extra hydrogen atom. And the next carbon number 2 we add OH group and this reaction follow Markovnikov rule because your alkene is unsymmetrical. So this is our reagent can be writing also, or the best you'll just write H3O plus. Okay, so for your information, hydration of alkenes also have a mechanism. Oh, so which one the mechanism? Kita ada 4 step, formation of carbocation, rearrangement. So I change similar step. This is a nucleophilic attack, and for the last part, formation of alcohol. alcohol. So the video for the mechanism you can study for the next video. So what happened in oxidation of alkenes? Oxidation of alkenes, we have a two reagent, potassium permanganate solution and ozonolysis. So chemical reaction is always occur pada carbon-carbon double bond. So if we use potassium permanganate solution, the condition must be to either cool the presence of basic, which is the OH minus exists, or hot in acidified condition H3O plus exists. So we start with the potassium manganate solution, but we use in condition cool. So basic, cool, and our reagent potassium permanganate, a reaction take place must be at the carbon-carbon double bond. So without heating, so the process involved, we need to add 2 times of the hydroxyl group neighboring adjacent together. So this product we can call 1,2-diol. So, and also at the same time, KMnO4 can undergo process reduction. So alkene undergo process oxidation and KMnO4 undergo process reduction and will produce MnO2 solid. So the observation can be formed brown precipitate form. So this is one of the chemical tests to identify the presence of the functional group carbon-carbon double bond, because in our observation you can observe the changes of the color from purple color change to the brown precipitate. So this is a chemical reaction, carbon-carbon double bond, reagent, basic condition, and the condition is the cool, and we just added the OH group for the neighboring carbon together, and we have a side product, the brown color, solid brown precipitate form. So similar for another stage lah. So if the cyclic compounds tak jadi masalah, masih lagi berlaku pada carbon double bond, from the double will become single, and we just add 2 times of OH group and the side product Mn2 precipitate form. So how about in a hot condition, which is we supply heat? So in a hot condition, you must be write your reagent with a step numbering. Number 1, it's only involve potassium manganate solution, basic condition and heat. Number 2, followed by H3O+. These writing are compulsory during you write in chemical equation. So according to the process involved, okay, either you write reagent plus here, numbering is a compulsory, number 1 solvent base and heat, number 2 followed by acidify. The reaction take place is the carbon-carbon double bond cleavage, so means a bond breaking occur at this part. So bila hot condition is applied, so the carbon double bond here will separate into 2 parts, plus C, half of the bonding here, and this is CH3 and H. So we can trace here, at the carbon-carbon double bond we have hydrogen atom, means this side can undergo process oxidation again. So this is, we use a strong oxidizing agent, oxygen will added to the half of the double bond here, and this hydrogen can be oxidized again, finalized, it can produce OH. Similar for this part, OH2. So this is why we are produce carboxyl 2 times, because we use a strong oxidizing agent. Okay, so what happened for this example? They are adjacent but CH2 at the end of the chain. So this is a acidify KMnO4 hot condition. So this part we divide by 2 area. So CH3, C, this is we have hydrogen, half double bond, plus C, H, we have a 2 here, half double bond. So the process involved, we use a strong oxidizing agent. So this strong oxidizing agent, first step, we just add oxygen at the half of the double bond, and this part we have the hydrogen, so it can further oxidize to form carboxyl group or H side, but at the end of here, it's produce methanol. So we use a strong oxidizing agent, so this will undergo cleavage. So this part will undergo process oxidation again, and it can produce CO2, carbon dioxide, and 2 hydrogen here undergo process oxidation, and it can produce H2O. So this is why your product first, water, carbon dioxide, and carboxyl group. If your carbon-carbon double bond at the end of the chain, and we have the CH2 at the end of the chain without branch. So, if we have this example and the potassium manganate solution acidify and hot condition, so the cleavage of the carbon double bond occur. So we draw separately half of the area double bond to trace the what is the product form, okay, plus another half of a double bond here. So the chemical reaction take place. We use a strong oxidizing agent. We just add the first step, oxygen at the double bond, and we trace carbon C double bond O. This carbon only attach carbon, no hydrogen. So means the process involved still remain as a product ketone group. No need to further oxidize. So only ketone group form. Okay, so how about the ozonolysis of alkenes? Okay, if the question given to you, the statement in ozonolysis mean our reagent must be ozone, but your writing also compulsory must be right. Number 1, ozone. Number 2, our condition either zinc, water, or CH3SCH3. So the process involve also cleavage of a carbon-carbon double bond. So remember for this part, ozone O3 is a mild oxidizing agent. So if the side product kita adalah aldehyde, it cannot be further oxidized in carboxylic acid. So as a conclusion here, the process ozonolysis, no carboxylic acid form. It just remain to produce a carbonyl compound, either C double bond OH or C double bond O, C and C, which is the group of aldehyde and ketone. So the chemical reaction take place. The first step, number 1, carbon-carbon double bond reacted with ozone, and we just undergo process a 2 addition of the 3 atom of the ozone, and this is ozonide is unstable. If the unstable, we must be reacted to the condition zinc and the presence of catalyst, and the bond breaking occur. When the bond breaking occur, so the final product kita adalah carbonyl compound, either aldehyde or ketone, depend on the structure given. So according to the general formula, if the reaction is ozone and the condition zinc and acidify, which is the presence of the water, and also the another condition, so the cleavage occur at this carbon-carbon double bond, and you just divide by 2, R, C, R half double plus C half double, R, H. So we use the ozone as our reagent. So the process involved, ozone is a mild oxidizing agent. The process we just add O at the half of the double bond. So enough, we just produce either aldehyde or ketone together. So according to the example, reagent is ozone. So what happened? The cleavage form. Okay, the bond cleavage occurs, so you just apply oxygen at the half of the double bond. So one is the ketone, second one also ketone. So which one, aldehyde or ketone form, is depend on the structure of the reactant given.